Hello friends, today I am here to continue the topic sound with the characteristics of sound wave, and I have slipped into my comfort zone. I have brought a chair and now I am going to teach you the four major characteristics of sound. Those are frequency, wavelength, amplitude and time period. Further going on to the minor ones. So first let me explain you what is wavelength, because that would make you explain it better, the frequency and the amplitude and the time period thing. So first I'm going to draw a transverse wave and a longitudinal wave. And a longitudinal wave. So, what is wavelength? Wavelength is basically the distance between two successive crests or two successive troughs or the valleys or two successive crests, that is the uphill. And if we take it in a longitudinal wave, then we would say that the distance between two successive rarefractions or two successive compressions. So this is what is wavelength, and the definition for wavelength would be the distance between two consecutive troughs or crests, or distance between two consecutive compressions or rarefractions. So I hope you have understood what is wavelength. Now let me go on to frequency. When a sound travels from the source to the listener, there are a series of waves created. That means a series of wavelength. That means a series of waves in which there is one wavelength, one distance that is being repeated and repeated from the source to the listener. So, how much time one wave is repeated, that is the frequency of an object in a unit time. So, let me simplify this. Number of vibrations in a unit time is the frequency. I can explain you it with an example. If you beat a drum and you are beating a drum 10 times in a second, then your frequency would be 10 Hertz, in which your unit time would be seconds. So the definition for frequency would be the number of vibrations or oscillations or waves per unit time. Beat, second, minute, hour, does not matter, is our frequency. Then comes our amplitude. So, amplitude is the maximum displacement from the mean. So, if we draw mean here, then the maximum displacement from here to here, which is the maximum, this one is the maximum, so this is going to be our amplitude. It can be on the valley side as well, that is the trough side as well. So like this. And in a longitudinal wave, it can be in a compression or a rarefraction, depending upon the maximum disturbance from the mean value. This is going to be our amplitude. And there is a very simple definition for so-called time period. The time taken to complete one vibration, oscillation or a wave is our time period. So it's going to repeat every time, and for calculating the whole time, we're going to multiply how in frequency into the time period. So like that, we get a relationship between our frequency and the time period. Because I just told you, if you want to take out whole of the time, what was the time from the source to the listener for that sound energy to travel, then you're going to multiply the time period into the frequency, because our frequency gives the number of waves they're going to come till the source to the listener, and the time period is the time taken to complete one wave. So we would do frequency into the time period to get the whole of the time period. So if we want to take out frequency, then our relationship would be somewhat like this, that frequency is equals to 1 upon T. Our frequency is actually represented by a symbol called nu, but I have a serious problem in drawing that symbol, so I'm using F instead of nu, but you as beginners or learners, you can use that nu symbol. That's a nice idea. And so I'm going to head on quickly to the speed of the sound. So, speed of the sound is just a very simple concept. As there is a speed of a car, there is a speed of a helicopter, there is speed of an aeroplane. Same is with the speed of the sound. The speed at which the sound travels from the source to the listener is the speed of the sound. It is the speed. So in normal, if you are taking out the speed for a vehicle traveling over a distance, then you would do it as follows: that our speed, or what we call V, velocity, is equals to 1 upon t. Same can be done with distance upon time. So same can be done with this also. And wavelength is represented by a symbol called lambda. So I'm going to use it in this formula, that our velocity, or the speed of our sound wave, is equals to our lambda, that is the wavelength, to complete one wave, upon the time period, the time taken to complete one wave. So we will get the velocity for one wave, and then you're going to multiply it upon the time. That does not matter. So you're going to take the velocity or the speed of the sound for one particular wave. So that would be done as our speed or our velocity is equals to lambda upon t. Here lambda represents wavelength, so wavelength upon time. So just before some seconds, I told you about the frequency and the time period relation. So if you're told that you want to have a relationship between velocity or the speed of the sound and the frequency, how would you do that? You are already given that our frequency is equals to 1 upon t. So if we want to find out t from here and remove this t from here, then we can get the frequency inside it. So we will do it as follows. T is here, so t would come here. This would be removed from here into t. So now f would be removed from here and it would come here. So our t is equals to 1 upon f. So here, when our t is equals to 1 upon f, here our t is getting divided by the lambda. So we're gonna reciprocal it, and it would come that our velocity or our speed is equals to lambda into the frequency. So this is another formula, that is the relationship between lambda and the velocity and the frequency of the wave. So I've told you a large number of things. Let us write those down so that you don't forget, and that comes into your mind whenever you're seeing those points. Note them down if you want. So I've told you about the time period, the frequency, the amplitude and the wavelength. The next thing I told you about was our speed or the velocity of the wave at which it covers one wave, the speed it has while doing that. That is our speed of the wave, and it is influenced by the temperature and the type of the medium it's traveling through. So speed is dependent upon two factors: the type of the medium and the temperature of the medium. Because you've got that kinetic energy thing. When the temperature is more, then the kinetic energy of the particles increase. As a result, they travel faster. So it depends upon the temperature. And second thing why it depends upon temperature is that when temperature is more, the density decreases. As a result, it can travel more distance. So I've told you about these four things. Now I'm going to tell you something about pitch. No need to get confused. Pitch is actually nothing but frequency. It is how our own brain, our two halves brain, depicts or interprets frequency. That is our pitch. How our brain interprets the frequency, that is our pitch. So I'm going to clear with the pitch, and now I'm going to tell you something. Okay, so you have the same pitch, the same loudness or the amplitude. Then what you're going to do to differentiate between two voices? Your mother is speaking from one side and your sister is speaking. They both have the same frequency and the same amplitude, and still you have to distinguish between them. So what would you do? There is a kind of quality or timbre of the voice which helps us in that state when you have both of the characteristics of the wave same. So we're gonna introduce a new characteristic of sound, that is quality. Quality or timbre. So a simple and a slow definition for this is gonna be when the amplitude or the loudness and the pitch of two voices are same. This is a feature that then enables us to differentiate between the two voices. If in a music system, a guitar and the sitar are played in the same amplitude and the frequency at the same time to bring out the music, to bring out that note, then you can differentiate between those two because of their quality and timbre. I just said a word note in between, did you notice? Okay, so I'm going to tell you something about note. Note, when performed with mastership and when it is performed as it should be, then it can come out very nicely and it can be very soothing music for our ears. But if it's not done properly, then it can be horrifying, sarcastic. So a note is a mixture of frequencies, different frequencies, different frequencies, so that you enjoy the music, you get in the rhythm, you get in the beat. So that is our note. And one is the music and noise. Can you differentiate between those two? Music and noise. There is a drastic difference between music and noise. Music is a sound that is very pleasant to hear. You enjoy hearing that sound. But noise is something that you get bored, you get irritated out of which you need to stop it. That is noise. Noise is a sound that is unpleasant to hear for our ears, and music is a sound that is very pleasant to hear for our ears.